Hi everyone, so now the second example, I'm going to be targeting building an object like a structure, or building an object through using a C structure that I then return to the user. Now, usually how this works is that you have some sort of a declaration of the object itself, and if the user is able to sort of interact with the object directly, you would put the entire structure's definition in the header file so that when you include it somewhere else, you know actually the structure of what's inside of the struct. And then you return, you create like some sort of an init function that will then create an instance of the function of the object and return a pointer to that object to the user. Now, the disadvantage of this is that the user has complete access to the object. So essentially everything, all the data inside of the object is public, but you can then again just sort of say, hey, yeah, it's a really nice approach. And for a lot of you, this will probably be the optimal approach because it's quite, it's not that complex in terms of like just C stuff. But then you can sort of still write functions that take in a pointer to an object as an argument to then do things on that object. And so we'll do that now. I'll create a string object where I'll have like a pointer to a string, and then usually like you would have in other languages where you have like actual string types, store the length of the string, which is really good really good practice, I guess, because in C, you don't have the explicit string type. You just have an array of characters, which are hopefully null terminated, right? So, and then we'll create a couple of functions to return the string to you or return the length, and then also to set the string's content. And we'll see why this is useful, because if you want to try and allocate a string longer than what the memory that's been currently allocated, you'd have to, for instance, reallocate more memory, right? So, now we're going to have a structure in here, a struct, call this myString, and we'll give it a couple of members. We'll give it an int, or even more appropriately, we'll give it an unsigned size t, string length, and we'll give it a char pointer, and we'll call this is the string. All right, and so now we'll go and include, I think we need standard int. Include std int, I believe, is what I need for using size t. We'll see. Okay. So now we have inside of a header file the definition of what the structure looks like. So if I want to go to my main, I can just straight up, because I've included my string, I could create one of these. So I've called my structure string myString. So we say struct myString my string structure. So we can do this. Like if we want to zero out the instance of it, we have now, we have now created an instance of this here. So we could then just go and say, hey, yeah, my string structure, my string structure dot string length equals 2. And if we make this, if we debug this, and if we break on 13 and run to 13, if we print my string structure, we can see that we have 2 saved in it. And we have the string, which is this char pointer, and it's obviously 0 because we haven't allocated it yet. But this is why you would put the structure in your header file, is because that when I then include my string, I can then instantiate these objects pretty standardly. But the problem with doing this instantiation like this is that that there's nothing stored in this char pointer. And so how you would use an object like this, my string, would be that you want to create it to store some sort of a string, right? And so you would usually create a init function that allocates the structure and the string, like the char pointer, and sets the char pointer content and then returns the pointer to this sort of initialized structure. And so we'll do that now and see how this works. So what I want is how when I write my when I'm writing my modules or my code, and what you should probably also do too when you're doing your project, is I think about what functions do I need to expose through my API, and then I write the functions in my header file, and then I can go to my C file and just start filling them in essentially. And when you sit down for your project, you can probably say, hey, okay, cool. Like if we go with Space Invaders, which will probably be the game for this semester, you have like your mothership and blocks and a bullet, and you can create create a mothership.c, a mothership.h. You can decide the functions that you need to expose, like, yep, we need a function to move the mothership.h one step to the left, move the mothership one step to the right. You can then fill these into your header file, and then at some point in time, you can come back and fill out the C file to actually do the moving. And so what I'm going to do, I'm going to think about, okay, cool, in my header file, what functions do I need to work on my string structure? So I want to have some sort of we'll have some sort of an init function. Now we'll have int, well, it's going to return a char point. So it's going to return a struct. It's going to return a pointer to a structure that has been allocated. So it's going to return a struct my string pointer, and we'll call this my string init, and it will take in a const char pointer to the string that you want to set to store in this structure. So what we're going to have to do is we firstly have to allocate the actual structure that you're going to be returning, meaning we have to allocate memory the size of a struct my string. So we're going to say, what I normally do is I make a variable called ret, which means that it's the return variable. So we're going to make struct my string pointer ret. Now we have to allocate this guy in memory. So I'm going to use calloc because I want to make sure that everything's zeroed out, because then I can also make sure I can check that string, the char pointer, for instance, is null, because it will be automatically zeroed out to null. So we'll use calloc. I'm going to allocate one item size of struct my string. Finish you. Now we can do some error checking, and this is where it's useful to have these init functions, because there's this inbuilt error checking. And so I can say if ret equals null, because if we go down and we look at manual for malloc and we look at the return value, we can see that on errors these functions return null. So if calloc fails, ret will be null. So we can do error checking here and say if ret is null, return null. Meaning that we can, when we're using this function, check that if the thing that we've allocated was null or not, knows that if it's been successful or not, right? Now we have allocated our structure, but now in here we actually have an array of characters, which is our string. And so in here we have the input string that we want to put into it. So we need to know how long is this array. Now we can find this out. One quite flexible way is to use string length, like strlen. So we look at the manual strlen, and we'll see calculates the length of the string. It takes in the string itself and it returns a size t of the length, excluding the null byte, right? So what we're going to do is we'll just say ret, now it's a pointer. So we're going to go into string length equals strlen the string. Oops, the string. Man, I can't type today. So what this is going to do is going to set this variable here to the length of the string that we've passed in the initializing call. Because then what we can do is we can allocate the actual string in here. There's a couple of different ways we could use strdup, which is strdup, which essentially duplicates the string. Was an explanation. Function returns a pointer to a new string, which is a duplicate of string s. Memory of the new string is obtained with malloc and can be freed with free. So we could just use this, but I'm going to do it the long way to show sort of just a bit more of an explanation. So what we're going to do is we're going to need to set the pointer to the string. We need to allocate this. Now, because we need a null terminated string, I'm just going to use calloc so that I can guarantee that the final character is null terminated. Now, strings work in C, which I hopefully you all know, is that they're essentially just an array of characters with a zero character, like a /0. It's the null character on the end. And with these functions like string length, how it works is it just goes through this array and just keeps counting until it comes across this null character. But if we look at manual for string length, it says here, excluding the terminating null byte. So we have here in our string length, this is the length of the string excluding the null character. So when we allocate the array to hold the string, we need to allocate this length of bytes plus 1 to store the null character. So this is very common in C that you'll see stuff with strings always with like a +1 everywhere, right? So what we're going to do is we're going to calloc. Now we want the length of the array, which is going to be ret string length plus 1. Because of the null character, and we're going to allocate each item is the size of a char, so 1 byte. And now we can do error checking, so we'll say if ret string equals null, we're going to want to return null, but we probably want to free this up first, because otherwise this is going to let left hanging and it's going to use up memory, and it's just bad practice to not clean up after yourself. So what we'll firstly do is that we'll free ret, and then we'll return null to say, hey, yeah, okay, we've had an error, but we've cleaned up anything that we've allocated first. And so now that we've got the string allocated, we can then copy the string in. Now we can use 2 different ways of doing this. We could use string copy or mem copy. Now I'll just use string copy because it's easier. And if we look at string copy, like I quickly used in my last video, copies a string pointed to by source, including the terminating null byte, right? Okay, so we can now go and strcpy, and it takes in, cpy, takes in as the first argument the destination. So we're copying into our ret structure, ret string, and now we want to copy it from the string. Now, now we can see return value. It returns a pointer to the destination, blah, blah, blah. We don't need this at all because we already know where the pointer exists because we've allocated it or we have it in our structure. But there's no error checking in this is what I wanted to try and get at. So essentially that's the end of our function, and now we need to just return the pointer or pointer to the object we created, this guy. And so we do that by returning ret, right? So there we go, we have a string. Now we've created a function to make string init. And just before I go to my main to test this out, oh, sorry, I've done all this in my header file. Whoops. I'm going to put this should be in here. And this, I need to put a declaration of it in here. And now what I'm going to do is I'm just going to create the other functions I want. I want functions where I can set a new string and get a copy of the string back, right? So what I want, let's say I want to function to set the string. So we're going to set an integer. So this is essentially just going to be a return, like an error code. So usually in C programming, you return 0 if nothing's happened, and you return some value, negative, positive, some, like you can have error codes, like a 1 is this error, 2 is this error, but essentially some non-zero value is an error. So I'm going to keep the prefix the same, my string set string. And now this will take in a constant char, the string again. So this will be the new string to set it. And then I want to have a function where it returns a copy of the string. So it'll return you a char pointer, my string get string. And then this will take in the object of the string. So you want to get it from an object, and so this will take in a struct, my string pointer to, we'll say the string structure. These names are terrible, but this is just to be very, very clear. Okay, so now we have these guys here, but we'll go and implement them in the C file in a minute. We're just going to, firstly, this guy needs to come down. Firstly, we'll include standard lib, and we'll include string.h, and that should get rid of all size of an oh, and because he needs to know what struct my string is and it's defined in the header file, we also need to include my string, sorry, with quotes, my string.h. And what are you complaining about? Struct my string. Yeah, I mean, that should be fine. Okay, so now we've filled out the C file, the function, and we can go into main and we'll use this. So what we want to do is we want to create, we'll make some sort of random string up here, const char pointer test string. This is the test. And then we're going to create an object. So my string init, my string init, and then it takes in test string. And so that should hopefully build. Now if we debug this, and I will break at 13 again. Sorry, I forgot. I should probably go struct my string pointer, our string equals, right? Because this is where we're going to store the pointer. We're going to store in our string the reference to the instantiated struct. So I'll just quickly make this again and then debug it. Break on 13. And if we look into our string, we can see that we have the string length stored as 23. The string has been allocated. It's stored here in memory, and then it's obviously got a copy of it. GDB is just showing us what's actually stored in that memory, right? So first, the init function works. We can pass in some sort of initializing parameters. This could be whatever you want. If you're creating a ball, I'll put in the size of the ball, the color, the starting X position, and then inside of your function, you just set all of these variables, right? But now we want to go through and we're going to fill out these two functions. So now I've written in my header file, I've sat back and been like, yeah, okay, cool, what functions do I need? I need a setter and I need a getter. So I'm going to take these guys and copy them down into my header file, my C file, and now I want to fill them out. So this is the same as when you're writing a report and you create dot points for what you want to actually write about. I essentially created my header file function prototypes as dot points, and now I'm going to go back and fill out all my functions. So set string, this is quite easy. What we're going to do is firstly, we're going to check, hey, have they passed us in, or I should have done this on my init function. We'll do some error checking to make sure they've actually passed us in a valid string. So if the string equals null, return -1. So this is return an error. Return error. Because this returns 0 on success, like most Linux or C programs functions, yeah? So this is just checking that we have an actual string here, that we've not been passed a null pointer. Because if we're going to go and try and do things later with a null pointer, we're going to have big memory errors. So now what we want to do is we want to reallocate the string length to be the right size. And so a really good function for this is realloc. And so what realloc does, if we look, where is realloc? Here. Changes the size of memory block pointer to by pointer, blah, blah, blah. The contents will be unchanged in the range, da, 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 da. Now the thing that is important, if the new size is larger than the old size, the added memory will not be initialized. If, da, 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 and then where is it? If it is smaller. For all values of size, if size is equal to 0, da, 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 then the call is equivalent to free, da, 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 da. Pointer is null, da, da, da. Yeah, so pretty much, da, 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 if in array, da, 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 da. Cool. However, I'm like, I've never actually read this before. This is quite interesting. Oh, okay. Okay, so anyway, what we're going to want to do is we want to make it maybe smaller, so then the old size added memory will not be initialized if pointer is null, and the call equivalent to malloc size for all values of size is equal to 0. The pointer is not null, and the call is equivalent to free unless the pointer is null. Da, 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 da. Wow, that's very in depth. There was room to. Okay. But anyway, so what we have to do is we have to reallocate the size of this guy to deal with the length of the new string. It could be longer, it could be shorter, it could be the same size. It doesn't matter. what we're going to do is using the realloc size here. Oh, it's a bit annoying how realloc works. It takes a pointer. So realloc here, if pointer is null, then the call is equivalent. But essentially the pointer to where you want to store it has to get passed to realloc, and it also returns the pointer to the newly allocated memory. So you sort of returns it and you pass it in. But anyway, so it doesn't matter, just follow what I do. So we want to take in, we're going to have to set, we're missing something here, and that is we're missing a reference to this structure in which we're going to do this. So struct my string, the string structure. And we're going to need to change this up here. Quickly format you to give it and then so now we know the structure in which we want to set the string. So we're going to go and reallocate the length of the string buffer inside of the string structure. So the string structure string equals realloc. Now this is where it gets weird. We put the pointer in again. And then the next thing that realloc takes is the length of the size of the buffer. Now what this is for us, we're actually better off now going in firstly the string structure. We'll firstly go and set the length of the new string into string length, the same as we did before. And we'll go string length, equals string length, and then this is the new string that we want to set, the string. Now in here, we'll go and now set, we have size of char times by this length, so the string structure, string length. Now this is where we have to go brackets +1 because we need space for that terminating character. So now we can error check it if the string structure string is null. We have a problem, and so then we want to, you could free it if you wanted to, but maybe you could just say, yeah, we'll free it. So we'll go free the string structure. Return -1, whatever. That's just how I've decided to handle errors in this case. But so then if it doesn't fail, we have now reallocated and we can use string copy like before. So we just go to string copy and we'll put it into the string structure, into string, and we'll put it from the string. Format this up a bit. And so this should be good. And so we don't need to return a pointer to it because it's a set function, but we need to say, hey, yep, okay, we've gotten to this point, we have no error. So we're returning 0. Now what call to insecure? Yes, I don't care about that. And so we'll go and test this now. So we can now go and set, let's create like, well, what we'll do is we'll print f the string, our string dot string, arrow because it's a pointer. And then what we'll do is we'll call this my string set string to this, or we'll have to put a reference to where we want to set it. This is the second string and it is longer. Okay, now we'll take this and we'll print it again. So, hopefully I've not missed anything. And let's run this. Why are you not? Oh, I didn't save my main, of course. Here we go. And we'll see we've reallocated and set this, and what we can do as well, we'll set, hey, we'll go S, and we'll say the length of length, percentage D, and then we'll put in here our string length, and we'll just set this up here as well. Save you, build it, and run it. And we can see that we've reallocated this buffer to be longer. It's 42, right? So we've done a setter function now. Now, normally you have set and gets, and so we're going to have in here, we've already written the definition for it, and we just need to fill this out now. So we're going to go and write what we want to do. Now we have to return a copy, and we'll use string dup this time because it's way easier. And we're going to return a char pointer, and we'll just say, or even easier, to like a single line, we just return, because if we look at the manual for string dup, it returns a pointer to us. Returns a pointer to the duplicated string. So we're just going to return stru dup to the string structure string. All right, so that's it. Super easy. Gets are usually pretty simple, but I mean, you could do some stuff in here, like if you wanted to return only the first 40 characters, then you could just chop it and return the first 40 characters. You can do extra things if you need to. And so what we'll do now is we'll just call this print, or we can say, string copy equals my string get string, and we'll say the object we want to get the string from, and then we can print f the string copy There we go. We have a copy of the first string through the getter. So this hopefully is a good example of how you create these objects. So we created the object here that we want to be able to like sort of instantiate, which we instantiate using an init. And so the init function returns an initialized and allocated member, zeroed out or whatever you have you. And you, for instance, could have put in more things in here, blah, blah, blah. Like a good example of this is if we go and look at the, let's just go to another window and quickly go to git GitHub, and I forget to free that in here somewhere. We'll go to look at TUM ball. So if we look at TUM ball, we'll see that I have created these objects as like the ball object here has a sprite, an X and a Y, a float X and a Y, essentially these other things that you're not really worried about, but essentially has a heap of different variables, which there's an init function in here somewhere. Now if we look on the left, there'll be, where are the functions? Why are you not there? Set ball location, set ball speed, create ball. Here. So in this is the initialization function where I'm putting in an initial X, color, radius, and all of these things. And if we look at the implementation, I'm allocating a ball structure and then I'm returning a pointer to it, but I'm also setting all of these initial variables to it, like create ball right here. So I'm firstly allocating this ball structure using the same like ret thing, and then I'm just setting all of these initial values here, which we can see, and returning a pointer to it. So when I want to create a ball, I pass in, oops, sorry, my screen is covering that. We'll see here that I'm creating the object and returning a pointer to it. So hopefully this makes sense to you. And now the next video, I will go through and talk about the same idea, but using handles, because that way we sort of hide the fact that I can here use string length. I'm directly accessing this variable and I can also set it, but I want to remove the functionality from the user to make really closed APIs to objects essentially. So I'm going to stop this now and create a new copy of the folder and do that in the next video. Thank you. Hopefully this helped.